what percent of the data fall between each quartile? That will be 25%. Number 4, what does it mean to say the data is right, left, or not skewed? The mean is larger than the median. The data is skewed right. And I say most of the time because it depends on the data, but in this course, every time the mean is larger than the median, it will be skewed right. Number 5, when is the median useful as opposed to using the mean? And this describes it, but the main thing you want to look at, if you have extreme values, it's better most likely to use the median, because the median is not as affected by extreme values as the mean is if you're comparing the median and the mean. And most of the time those are the the statistic values that we're comparing. Number 6, how do you calculate probability using various rules? Here's an example. It says the length of time it takes a student to finish this particular test is normally distributed with a mean of 70 minutes and a standard deviation of 5 minutes. Question is, analyze the output to determine the probability that students' times taking the test will fall between 55 and 60 minutes. Again, there's a few ways to do this, but I think the easiest way is probably to use mini tabs. So let's pull up mini tabs. Here we're gonna pull up, go to graph. You're gonna go to probability distributions, view probability. Okay. It's a normal distribution. Your mean was 70. Your standard deviation, I believe, was 5. Let me go back to remember. Yes, it was. I'm going to go shaded area, and I'm going to click on X value, and I want to know the probability that it's between 55 and 60, so I'm going to go to the middle. I'm going to type in 55 and 60. That'll give me the probability. If they want to know the probability that was greater than 60, you would use right tail and put 60. If you want to know the probability that was less than 60, you go left tail and put 60, so forth and so on. So here between 55 and 60, and we get 0.02140. And again, it's here. There's your solution, but you need to know how to get to the solution. Part B says what percentage of students will take more than 65 minutes. Same process. Let's go back. Good review. Graph. Probability distribution plot. View probability. Click OK. Same data. Shaded area. This time greater than a value. So I'm going to go right tail. I say a value because I forgot already. Greater than 65 minutes. So I'm going to go here. Type in 65. Click OK. And it's 0.8413. 0.8413. And that's it for that one. The next one, if 1,000 students are taking the test, how many would you expect to take more than 65 minutes? And that one, you simply multiply 1,000 times the probability of that occurring, and you get 841, technically 0.3, but you can just round that to about 841. 842 students would be fine. But if you're rounding, it would be 841 students. Okay. Number 7. How do you find binomial probabilities using a binomial table? Or the problem may say that, but again, you always can use mini tabs to do these. It says historically, 82% of graduate, 82% of, that should be students, graduate from high school. I'm going to put students. Graduate from high school, a random sample of 10 students are selected. Assuming independence, find the probability that at least 5 graduate from high school, at most 5, so forth and so on. This is a binomial probability distribution. Here you're going to go to mini tab. This is, let's see, out of 10, 0.82 is your probability for success. You have n, which is 10. And here we want at least 5, which is basically the probability of x equal to 5, 6, 7, 8, 9, or 10. And the next one is at most 5, it's up to 5. And let's pause.